Yes, sir.
Why did Corvettes use the 302 motor?
Question is, why didn't Corvettes use the 302 motor? Corvettes ran in B and A production in road racing, and they were allowed to run either 327s and 350s, whereas SCA Trans Am Racing was limited to 305.
Well, aside from racing, just stock ones. They never put 302s in the vets.
It's kind of a great question too, because the 302 was an artificial displacement, right? That was made specific to compete in Trans Am. Right, exactly. So what they were going to enter into the Trans Am was the Camaro. And Corvette, they had their own program going on, so it was kind of segregated out that way. It's a good question.
The early Corvettes used a 283, which was the same stroke, smaller bore.
A lot of people used to take a 327 block and put the 283 crank in it. And the question always becomes, why would you decrease the horsepower, right? Because the 327 had more power, more torque on the lower end.
Well, that's what I think. Duncroft needed torque. I think a lot of vets were actually heavier than.
And again, we go back to the principle that the 302 was brought on to satisfy, you know, a need, right? A very specific need. Yeah, exactly. Good question. Good. Any other questions?
Oh,
yep.
Could the 302 benefit from a longer run?
I don't know if, you know, Smokey Unick, I wish he was standing here because he could probably explain it a lot better than I could. But I'll let you guys think. I'll kind of explain what we're seeing when we see what the rod does, and you can think about how that's going to work. Because to me, that's the great thing about engine building is there's a lot of theories, and the absolutes are, does it work? Until we try it, and basically, sometimes the absolute probably will work. We just don't know how to put all the things together to make it work.
What was the question, Dennis?
The rod length. He was asking would you benefit from a longer rod? So basically, you put it. You guys you probably know this, but the longer rod basically, when that piston comes up to top dead center, it's going to dwell a little bit longer with the longer rod. The shorter rod is not. But the speed difference when it goes down, if you have the same stroke and that rod's coming up, if it stays on top longer, well, at some point when that comes back around, that rod, the piston speed's going to increase. Is that good or bad? Now, that's all over the board on people's theories, and I tell you this because I've tried it. I have Xfinity Nationwide motors that have 6,200 rods in them and 6-inch rods in them. Hendrix 6,200, Childress for a long time 6-inch. PME 6,125, and they all work well. So sometimes I think we do things and we believe in things because it amuses us, you know, and whether it's right or wrong. But the big thing is, I don't know if it's a minute enough change where we haven't figured it out, and there's smarter people than I that have, but it's basically that combination. You know, when you build something, we're all pretty close at the level I'm at. We're all very close. So it's the little tweaks that I do, and hopefully I can outdo the other guy. And the same with you, with what you're doing. If you know if you know you got a cross ram, which we were talking about this morning, and Wayne was saying, you know, you've got this cross ram, and you've got a stock exhaust manifold. It's not complimenting it.
Yeah.
But if that's what you're trying to do, I guess that's a whole different deal. But if you're looking at the performance thing,
yeah, I'm just kind of curious because there's somewhere there's an optimum rod to stroke ratio.
Well, I think that the rod that's in it is pretty good. And then they have a 5.7.
So they got lucky.
Yeah. Okay. No, they didn't get lucky.
By design.
By design. They looked at piston speed. They looked at basically the box they're in. Yeah. Just like that manifold where Jerry was talking about it. They had to fit that under the hood. Yeah. Well, that tall thing right there, when they did that seemed like that was kind of trial and error when we looked at it. Yeah. And maybe it was, I don't know. But then when they said, yeah, that makes power, we've got to lay it down so we can keep the length and we can close the hoods.
Yeah.
You know? And, but they had a box they had to design it in, and I think it's the same thing with that rod. We look at, one engineer may look closer at friction and piston speed. Another one looks at dwell and spark. You're looking at the camshaft when the fuel's coming in. One thing affects another thing.
Yeah. Oh, and then piston weight, all that other stuff.
Yeah. It all matters.
In the, this is kind of expanded on that. In the early 70s, Bill Jenkins came out with the Chevy small block book that was the Bible.
That was my first book.
Me too.
Yeah.
I wore them out.
Yeah, the first guy I went to work for that gave me that book. The first week I was there, said, here, read this.
I used to have to read that book every 6 months to learn, to figure out more and more on it.
Sure.
But back then, the number was 1.9 was the rod ratio that he liked.
Yes.
Now, you read about Smokey Unick in his book, and he says, put the longest rod you can fit in there, because when the piston comes up, the combustion cavity stays smaller longer to build up the charge and rod angle.
That's right.
Now fast forward to Ray Morrison, and he's talking about all this and that. They did some work for Chevy on rod length, and he says, out of all the considerations, that's somewhere around below 9 or 10 the things to do. Just figure out a decent height for the ring package, the rod, and just connect it to. He said they didn't really.
That is, for me, I look more at the structure of the piston.
Right.
So if you where is that wrist pin? Where's the mass at?
Right.
That's
and
more important.
You get your skirt so it's stable.
That's right.
And the 4-stroke and everything.
Yeah.
But that's kind of where it's at. But like you said, with the longer rod, like Smokey said, you know, it holds that tighter. But see, a shorter rod, like the Pro Stocks now, they're pretty short on the connector rods. They want that rod to pull on the intake port faster.
That's right.
You know, so it draws down like that. So, like what you say, it's exactly right. All the parts have got to be shaking hands in conjunction with rod length, port volume, taper on the port, valve size, and all that. So it's one question. You know,
Yeah. This guy just made our case about good engine design, right? Exactly.
It is. It's
well, even today, not knowing much about it, there's computer program. What's this?
Bam!
That's your badge. that's your
Did you
badge.
come here with Joe Stepp?
He's looking for a job.
I've known Joe for 30 years.
I'm over that against
He
you.
built our oil pans for. He still is the man.
Joe's good. No, Joe's all right. What were we saying? No, but it's all about, you know, the combination of things and, you know, port volumes, runner lengths, taper, you know, reflect wave, you know, wave and reflective wave. And it gets involved, but that's what Jerry and those guys were doing with the runner length.
Exactly.
You know, when the valve closes, you get a wave that's set back up into the plenum, and the next go-round, you want that ram effect to force it back in.
Exactly.
And that's going to be timed in conjunction with volume, length, RPM, and all that. So you got to work with a cam guy. And
We learned back in the, and I don't want to get too far in the weeds on this, and stop me if I do.
Go.
In the late 80s, when the restrictor plate came out in NASCAR, Bobby Allison got in the fence in Talladega, and they realized that, you know, safety was someone's gonna get hurt real bad. So the next race they put a 390 carburetor on it, and then the next race they put an 1.25" 4-hole spacer on it, just a flat sheet metal spacer with 4 1.25" holes. Well, we went from, at that time our Grand National engines ran 625 horsepower. You put the restrictor plate on it, which is 1.25" holes, and we went from 625 to 400. 225 horsepower. 1.25" holes times 4. Now, we run holes that are 3/4 of an inch, and there's 4 of them, and we're making 425 horsepower. So, the holes been cut in half, and we're still making the same power because we learned how to optimize everything.
Yeah.
It helped us everywhere else. When they came out with that plate, that was in 88, 89. I was in a little shop in Redding, California with we had basically a video camera and a clear spacer in the dyno room because we had no idea what that fuel was doing.
Right.
And we had so much reversion in that you take the intake off, it was just black in there. And we learned that we couldn't run that big cam anymore.
No.
You know, we couldn't run that 278 degree duration cam. That's right. We had to widen it out a little bit. We had to go with a little cam because our restriction was so big.
And what kind of vacuum did they have in full throttle with those intakes full?
They had a lot.
Yeah.
But we also had a lot of compression in those motors too.
Right. Right.
So when you took on this whole thing, I don't know what year that was or how recent it was.
Tom can tell you, it was probably about a year and a half ago when we started this.
About a year ago. Yeah, an initial call. I called Wayne's criteria.
He doesn't need them. He doesn't need
Okay.
He's got a voice.
Wayne's criteria for this was very rigid. I had a gentleman that puts motors together and installs cross rams in Pennsylvania, not too far from here, and he did it for Reggie Jackson, and he was excellent. Wayne, no good. We need different parameters, and we wanted to do a next level build. And we kept searching and searching and searching. I reached out to Pat Busey. I'm sure everybody's aware of Pat. Pat suggested Dennis. I called Dennis, and we conversed, and he decided to take the project on. He thought it was pretty cool. You know, it was like something different, and he embraced it. And we started about a year ago. So we started to procure parts and send them in drips and drabs, and then finally we had everything there, and we did the project. And it was for Mark. Martin was here a minute ago.
Okay.
And Wayne engineered everything, and then he was very rigid with the specs too. The heads, the cam, he wanted certain pistons. He basically wanted to replicate what Smokey did, to honor Smokey. Because this was a Smokey, and Martin's car is a Smokey build, but it had to be able to drive on the street with no issues. And that's what we were attempting to accomplish. And with the motor, finally it all came together, and Dennis invited everybody over, and we came and we saw it on the dyno, and we were elated. We were elated when we saw the motor and the dyno shoots.
So how much did you have to study and go back and look at what Smokey did, or Jerry, or Chevrolet, and then did you kind of wipe the slate clean and try to reinvent the wheel, or how much of what they had already done did you build off of?
I took what Wayne, the parts they sent, not all the parts because we talked about it, but the basic package, and just built the engine around that. There was some things that you source now that might be a little different. I have an idea what I think is a better rate.
The timing chain.
The timing chain. I mean, there's some little things that you do, but really just the finishing. How do we finish the cylinder heads as far as the flow? After we put a valve job in it, we optimize that. And that's what the little things are in an engine. You don't always have to rebuild your engine and get the heads ported. If you have a good machine shop that has good equipment and knows what they're doing, they're going to pick that up. And that's, if you're looking for this much gain, you can get most of it without spending a ton of money. That last little bit. And that's what he wanted. We wanted to get every bit that we could. That's what we did there. Something that I got to kind of go off to is Wayne and I were talking this morning, and this is a credit to the guy I worked for 30 plus years, Mark Smith. Wayne said, "You used to work for Mark Smith," and I didn't know that Wayne conversed with Mark when he wrote his book, the guy that I worked for basically my whole career. He passed away 5 years ago. And so really for me, I'm the wrong guy standing here. I'm just the next guy in line. But that's kind of part of what keeps us alive in the history of cars, and particularly this package, is who's going to keep it alive and who cares? You know, you guys do because you're here. And you have pride in what you're doing, so keep it going. But try not to get it lost. You know, try to keep what happened. You know, because for the next generation to enjoy it.
Yeah.
That made another good reason why you were the guy, because you were a pupil of Mark Smith.
Oh yeah. When they said that, I guess that segued in, because when they came to me, they didn't know until recently. I don't know when Wayne figured it out. He asked me, "You didn't know last year that I worked with Mark?"
Nope.
He didn't know, but
no clue.
I basically, everything I've learned, I was his right-hand guy for his whole career.
Yeah, that's cool.
So it's kind of neat being able to be involved with this.
Serendipity.
There you go. There you go.
What kind of, did you guys go to a different plug when you went to the cross ram? Instead of running like an AC Delco plug, did they go to like an auto light? Because I run some auto lights and some like 302 stuff, and they run the gaps different because you have higher energy ignition, you know, that changes the gap in the plug.
Well,
Did you go to a hotter or cooler plug?
A little bit hotter, but I'd say that on the spark plug deal, that, especially in this day and age, that's across the board as far as where those things, the sourcing on the parts and the plugs over the years. I couldn't speak to what was good then and now.
I figured dyno time would read out a lot of that stuff, right?
It does, but I'll tell you, if you have an ignition system that has the proper voltage, most of the plugs they compare pretty well on the dynamometer.
And plus, with acceleration in a car, everything's going to want to come back to an acceleration compared to the dyno.
Right, but the dyno has, you're going to feel it when you load into it. You've got a pretty heavy load on the engine, but it's hard to find. There's very subtle changes, you know. But there is, you know, we have spark plugs in a race engine. If you look at percentages, a race engine that makes 800 horsepower, from a good plug, from the okay plug to a really good plug, is 2 to 3 horsepower. So you're looking at 0.25%. It's very small changes on a passenger car, other than drivability. That's probably more in tune with the tune of the engine.
Someone came to you and wanted to build a cross-ram motor. What cylinder head would you want to use? Would you want to use the cast iron or the trick flow, the ones that look like the old stuff, but out of aluminum? Or
I think that just depends on what you're going to do. If you're trying to build, if you're trying to keep
how authentic you want
an
it
authentic, you know, authentic platform, we know what you got to do. It just depends. If you're wanting to build a hot rod to go to a car show, or if that's what you want to do, then
Would you know how to look at the castings before shift and all that stuff to, you know, to see what heads you'd rather use, even if, you know, if it's a 186 head or a 69?
Yeah, for what we do, we're kind of, I wouldn't say stuck, but they're not making that stuff anymore, kind of like bland.
Yeah, right.
So we're gonna if someone brings an engine that has heads on it, we're gonna try to use those heads.
Yeah.
You know, that's kind of the box that we're in there. That cast it's done.
Right.
And I kind of look at it, if you're gonna drive something on the street, even with what we're doing, what does it run at 3,000? Or, you know, what does it run from the time you start it up? You're going through the gears, you have to pass that low RPM. Whereas in this engine, I guess this engine was made for Trans Am racing, right?
Yep.
It was designed because the rule was 5 liters, 305. So it was, they didn't care, the Trans Am racers they could care less about 3,000. They knew what they had, so they just turned them harder. You know, and you asked about drag racing and where you shift, like, you know, the engine in the street form, and it's gonna peak horsepower, you know, at 67, 68, right in that area. So usually you might see, because you keep the power into the curve, you might still see an overall gain if you shift it at 7 or 72. But if you go much higher, it's such an exponential loss that you're gonna suffer from.
Yeah, just a quick.
That 140 cam, I mean, that's kind of misleading because it's not just right out of the off the shelf 140 cam. They have special specs and everything that they came up with.
Yeah.
Right. That's what I was saying. You've got the roller.
It is. Yeah.
Cam, your design is now, for lack of a better term, it's a pleasure to ride.
Right.
Drive.
Yeah, and let me just expand on that point too. So when you make the comparison between the single 4 302 stock, right? The engine that we had put together outperforms it across the entire RPM range. Much more torque on the lower end. So if you are of the mind that it's 302 stock is a little anemic on the bottom end, this is going to cure that, right? And then it's going to give you gobs and gobs of stuff going on at the top. As a matter of fact, on the top end, it's going to start at one point feeling more like a big block, and it's going to confuse you. And it's never going to stop. It's just going to keep on going through the RPM range. It will probably go up to 7,800 RPM before you can even get away from it. As a matter of fact, the dyno run, when we were watching it, one of the things that I saw was, I think they were going to limit it to about 76 or so, and that thing just buzzed. After it got up around 76, it just kept on going. It's like going, wow, straight up.
Yeah.
But from that, right, it's just so fast.
And I have our dyno guy.
Yep.
He's a New Jersey guy, but I wouldn't say he's a world rest. But if the engine, I tell him, hey, turn this to 8,800, I can't tell you. It always, when I go back there, it's 92. he'll swear up and down that that's all he did. You're looking at it, and we worked.
He buzzed it.
We worked together for 20 years. You know, he does his thing and he knows what he's doing. But
He's a Copo guy.
Yeah.
He had Copo Camaros, real muscle.
Tom got to know him.
Dennis, and he's a neat guy. He's from North Jersey,
Yeah.
and oh yeah, we were going to regulate it at I think 72, and then Martin said turn it up, and he cranked it up.
Yeah, the owner was there, so when the customer's there, he tells you to do it. You know?
But another thing too, and let me just, when he buzzed it, they were 100% confident that that engine was going to stay together. That's critical. You want to do it right, you want to do it once. You don't want to have a catastrophic failure, right? So when you do it with the roller and you do it well like Dennis does, it's a done deal. And you'll never go back and say, should I have done it differently? You know you are where you're supposed to be, right? There's nothing more you can gain from it. If your goal is to optimize it for the street, you hit your goal, right? So that's basically it. But I just wanted to emphasize that from stock to where it ended up, absolutely tractable, drivable on the street, and it outperforms the single 4 by a wide margin, top and bottom and mid-range, all throughout. So it's a win-win.
So because of that story, what is the shift point? Like, where are you telling the market?
Where you want it to be.
How far can you take it?
How big are your balls, man?
So real quick, I had two people today. They asked me if we could do this with a Joe Parks reproduction. It so happens the next person in line, John Wheeler, he's from Florida. Dennis took his project on and he just started it. He has a Joe Parks cross ram reproduction, and he has reissue 4295s, and Dennis has taken that on. So that's our next project. We're going to see where we can go with this. So I don't think he's going to achieve the 480.
Probably.
You know,
Yeah. I mean, we can do that again, but this was
the pistons.
Yeah, that's
everything,
pistons, yeah.
Everything was custom, like not,
Yeah.
but it was.
if you make, I mean, realistically, the 60s are achievable pretty easy.
The 460?
The sticker, the 465.
Yeah, that's achievable, and really, we benefit in this day and age from what the pioneers did, you know, and I guess I was part of that for me as far as later recruiting being brought around those people. But the ring seal.
But the formula you used for that 480, be hard to duplicate, you're saying?
No, it wouldn't be hard. I think you can do it again. It's just that the effort was a little more. It costs a little more. So necessary.
How fast do you want to go? Remember, it's like, yeah.
Well, he's going to
He'll
duplicate the heads. And,
would there be less time and money spent because you know how you got there now?
That's a good point. He's asking if you've already done it, why would it cost more? That's a good point. I think
hopefully Martin isn't here, but you know everybody after Martin would benefit.
That's right. That's right. I would say the flow of the heads, just the time we put into it. Yes, we probably could. We probably could. Probably will.
Well, I would think anybody has a cross rim now is all, oh, I want 480.
It remains to be seen. Now we have this Joe Parts intake. I don't know.
Yeah.
Maybe
there's some variables.
Is he going to get the same head work done? Is he going to get Hunter to make him the cam?
The pistons are going to be critical because
he's not getting the same.
He's not getting the slipper skirts on the ones that we used, much shorter. Yep.
Yeah.
Right. So the pistons that we used they were custom pistons, exactly the same as like the TRWs, but the difference being that the slipper skirt is shorter and they're stable. There was a flaw inherent to the original 302 pistons, the TRW style. You'll probably notice if you tear down a 302 engine, you'll always find that there's a lot of scuffing. And those skirts are way too long. And
that was a custom piston?
So what we did was we got a custom piston. The gentleman called them the smoky piston.
Pistons.
And but what they were the same basic, Ford piston, but slipper skirt, much smaller. So you got less drag, it's stable, it's fine, and it picks up that additional power. Yeah.
And then also Hunter from
Camcraft?
Yeah, he produced the cam for us. He took the numbers from the heads and the flow from Dennis Gate, and he produced the cam probably, I think it was $299 when it was all said and done.
Unbelievable.
And he custom made that at his shop. He's in North Carolina too, isn't he?
He is.
Yeah.
Can I talk about cam for a minute? And I want you to jump in too. So the question comes up on cams all the time. It's like, what cam do you recommend? And then everybody's going, what about that off-the-shelf cam? I don't know. Name one variety, whatever. It's like Iski cam, right? And they'll give me numbers on it. And with what they just gave me, there's no way in the world I can even understand what that outcome is going to be. Because as we talked before, it's all about good engine design. You start at a point, right? And then you understand what your parameters are, your constraints, your limitations, go to the heads next, right? And this is exactly what the process that we followed. And this is just basic engine design. So then when it came down to the cam, now we're matching. We understand what our flow is from our heads. We understand our swept volume. Now we're going to match our cam to that. And we're going to make sure that we're not over-ventilating it. We're going to make sure the duration is the right duration, all of those things. And I think that's really where we came out. I had data from Jerry back in the late 60s, reams and reams of data that he had produced. And then over time, I've done my own work on it. And then just recently with Dennis and also with Hunter Webb. So we always try, and we were talking about 360 Deming model approach. It's kind of like where you measure something, you improve it, you measure it, you go back, can I further improve it? Were there any failures as a result of it? And what we did was we determined that where we were with that flow number, there was nothing more to do. I mean, we basically optimized it to meet the goal, but remember, it's all about the goal. It's about what you expect out of it. If you want your engine to be running on the street optimally, with the broadest range of RPM and power across that range, then you might want to consider getting the head work and getting that finalized because again, swept volume is going to be what it is. Think about your heads, and now you design your cam. Wherever you end up in your heads, now your cam comes into play. Always think about quality parts. There's a lot of stuff out there for the 302 that is not exactly quality. They're making reproduction, and I don't know, are they Icon pistons? And I don't like to talk about brand names like this, but they may not be the best choice. You might want to spend a couple $100 more and have a custom piston made that is more suitable. So always make that consideration. Budget is one thing, right? But endurance and durability and, you know, where you end up, a couple $100, you know, is well spent. So I want to ask you a question. How many cross rams were made?
Now, can I answer that with everybody, with a general?
You can answer it.
Okay.
But you have to answer it, and you'll get one of these. Here, a sticker.
Thank you, Wayne. Okay.
But you got to answer first.
So,
no, wait. Okay. You gotta.
Do I have to be?
You have to make sure that you answer it with how you got there.
Okay, so over the years, the question's always posted: how many cross rams exist? Real GM winters. I see the same answer time and time again: 500, 500, 500. 450 were made, 50 in the uh-oh pile. Somebody took the uh-oh pile, kept it, and started dispersing them on the street. So I know how many were made. But if I had, prior to knowing, my guess was 150. So.
Anybody else? Ideas?
Okay.
Whoop.
It's cheating if you're here yesterday.
Right.
I won't cheat.
Go ahead.
Wayne, did you guys use any of the crane heads that were done with the cross ram? Remember Crane had made heads in 69 block Crane?
I don't have any data on that at all. No, sorry, can't help you there. If you give me flow numbers on them, I can kind of give you an idea of what to expect, but...
He probably knows the man in the yellow hat.
Okay, but before we go back, I just want to finish the conversation on the number, right? Anybody else have an idea how many cross rams were made? Thousands?
Did you just say Chevrolet though?
Okay. You got me. How many GM cross rams were made? Okay.
You're talking multiple years, right?
Yeah.
Right, across all years.
3 years.
2.5 years.
All right, Wayne, 3 years.
Go ahead.
Say 500.
So interesting.
So he walks up and he says 500.
Everybody. So that is common. Everybody comes to the number 500. Now, I want to explain why. 500 was an artificial number that was created by the SCCA, Trans Am. In order to homologate, you had to have a certain number of production, whether it be service parts or whether it be RPOs. It didn't matter, right? So with that in mind, nobody really knew the number per se, but the thinking is, well, it must be 500 because they homologated for the SCCA Trans Am. The way it really went was, what they did was, Chevrolet as a business, they're not going to overproduce, right? So what they did was they went back over the last year Trans Am in '67. How many cars were competing? How many cars did they want to make sure had the advantage, right? So they enumerated that. So they projected, as a business would, it's just forecasting is all it is. And what they looked at was 68, who would be involved. So they had, in 68, in Daytona and in Sebring, they knew that they would have Penske and Smokey was going to be in. So those were 2 cars. They were going to probably have Horschler and maybe 2 other cars. You already have a number now. And then add to that number a spare. It's pretty low, right? And then as it went on, then they projected how many more cars, how many engine builds, and so on. So in a full year, you come up with prototypes. There were 25. We know that. So those went out immediately. So that satisfied Daytona and Sebring. And then going forward, the interim version of the same, that completed the entire 68 year. And when you look back at those numbers, it was closer to like maybe 125. And so then times that the next year for forecasting again to about another 125. So extrapolation only is that probably no more than 235 were produced. Yeah. Is that, did he guess?
He said a little over 200. Give him a sticker.
Sticker.
You got another one.
And I
Bam!
am half owner in a cross rim that's on a car
Yeah.
Oh, no kidding.
that we bought in 1971.
Oh, no kidding. Was it on a car running in 71?
No,
Great. And he just
No,
gave me a carburetor, a good one for one.
the
4295.
Yeah.
Oh, sweet. Very good.
it's been running on a Z for the past 20 years.
Okay.
And the biggest thing that has helped that car is a special made Muncie with a 297 first gear.
297.
297 or not 296.
Because what I do for fun is I'll create a M22 low helix gear, but 261, almost like it's an M20.
That's the way to do it.
Yeah,
He's
yeah.
got the 222nd gear.
Okay, very good. Excellent. Good. Thank you.
I have a question based on that, and just because the JL8 stuff is up here.
Yep.
How many JL8s did they make?
So there's a number. Does anybody know numbers of RPO JL8?
It's like 206.
206. And again, extrapolation, right? I mean, it was a number that Chevrolet had to produce a number that they could give to the SCCA Trans Am. And in this case, they came up with an abstract number to say that we're well on our way to 500. And as long as they showed in good faith that they were on their way, and then besides that, if they got caught or if they were audited, what they could do is they could show that all of those Corvette parts are the same parts and qualify them. I'm going to go out on a limb. You asked the question. How many were really made?
You have the 206.
Are you talking about the
HD
tapered
stuff,
axle,
right?
production one?
No, production JL8. Yeah, different, right?
So you have the 206, and then you'd have the HD ones, right?
Right. So we already know that the Cross-Ram number was much smaller, right?
He's talking production
Production.
cars that were produced by
JL8.
JL8 at the factory. That's what that's the
Correct.
question. Not how many
Well,
over
I'd
the
like to
count.
know both, I guess.
All
I'd
right,
like to know how
so
many
you don't
JL8,
want to know
how many-
this.
So the service package, I can't tell you.
Okay.
Just no way to know. But just go back to the premise of the
Jerry, Are
Cross-Ram.
you listening to this? Are you going to listen to Wayne's answer?
So the-
Because you're going to be stunned.
The Cross-Ram, approximately, right, 235, somewhere around there, which is much lower than the 500. And now we know why that 500 number abounds, right? The same thing now we know about the JL8. So they came up with an abstract number. Where did that number come from? Nobody knows, right? But the reality is it's probably half of that number, RPO JL8s. Half of that number. Yep.
103.
Yep, yep. When you go back and you try to enumerate how many were made, how many are out there, it's difficult, right? Because how many of those cars exist today? How many, well, so it's interesting. You know what's funny? You know what's funny about what you just said? I was actually going to start off the seminar by saying, welcome, hey, we're at the, how many, I've never seen so many 69 Z28s in one place at one time. As a matter of fact, I've never known that there's that many produced, right? So it's like when you think about it, wow, there's a lot of Z28s out there. But the bottom line is that nobody has a real number, but whenever you saw those numbers, there were reasons that they provided those numbers, and they were really just artificial numbers. That's all they were. There was somebody.
Back in '69, when you ordered a Z28, did you order the Cross-Ram with the car? Was it available? The reason I'm asking this question is I know I have a Cross-Ram car, which I bought the Cross-Ram in the early '80s. This is '69. It didn't come with it on there, but I know this guy that lives, well, not too far from me. I don't even know if he still lives now, but he told the story that he ordered a '69 Z28 Children's Chevrolet in North Carolina. And when he went to order it, he told the salesman that he wanted the Cross-Ram intake and the JL8 option, but the salesman at the time said didn't know what he was talking about. He had a hot rod book, had done a feature about that. Anyway, he got to look and he said, "You're right, you can get that." So he said he ordered a '69 Z28 with the JL8 option. And he said he got the Cross-Ram with it. When he come in, he called him and said, "Your car's here." They actually still had snow on the car. They unloaded it and pulled it in the service area, and the Cross-Ram was in the trunk. said, and he tells the same story the same way, it never deviates.
Yep. So the question is, could you order a 69 Z28 with a JL8, depending on what time of year it was, right? Because it was a half-year option, right? Yes. Could you order it then also with a cross ram in the trunk? Is that how it was delivered?
They come in the trunk. He said when they unloaded, they pulled in the service bay in the back. He said it had the intake, carburetors, and all kinds of linkages, is the way he described it, in the trunk. I really I'm asking this question. He tells it, he never deviates from it. I know how people,
Yeah, understood. Understood.
Same story every time. He said,
so on the dealer information on your checklist, there's no RPO check for cross ram, heavy duty service part. So you could order it through the parts dealer, but it could not really be delivered from the factory with that.
they couldn't come in the trunk.
I would say, I would debunk it. Yeah, yeah. I've heard the story too. Yeah.
You haven't said much about the carburetors. Did you guys change the jetting? Or I know the carburetors were set up with the floats were different for track racing versus drag racing.
You see this right here?
Yeah.
That's a problem, right?
The blackness.
And it talks about what Dennis was talking about before. If you don't have the entire system tuned correctly, it's a tuned system. What you got is reversion and you got everything's pushing back. That's because the cam was probably incorrect. Timing was set up incorrectly. The carburetors, when we talked to Jerry about this, the 4295s are calibrated perfectly. With the 69 in front, 71s in the back. Progressive linkage, you've got the linkage that's opening up half throttle. That's where you want to be. The 4210s opened up simultaneously without any. You've got these opening up the same time, and all you've got is air coming in. You don't have enough gas to enrich in it. So those were flawed. That was the first design. Second design fixed that, and what they did was they put in progressive linkage, so the secondaries come in half throttle, and then in the rear you've got.
Those are prototype carbs?
No. These are original 4295 3 digits.
So the cam, when you see this, primaries are opening, half throttle, now the secondaries will open. So
Everybody see that? Right here. And then bam.
Yeah.
and the other thing that made this calibrated correctly is that it has a secondary pump right here. So when the secondary begins to open, that air is enriched with the gas from this pump. So the point about this is, to answer your question, that was calibrated perfectly for the cross ramp. That was like end development, if you will. But remember, it's only calibrated in concert with the right head work, the right exhaust work, and the right camshaft.
You guys, when you changed that,
Yeah, I'd have to go back and look. We rejetted it. It wasn't far off though.
I'll interject. So there's Dennis too. He played with Martin's carbs. Allstate is our go-to guy for the carbs, and he worked in conjunction. Jarrett works in conjunction with Wayne on how to restore them, and he set them up 100% factory. With that being said, they went to PME, and Dennis, we call him Dennis 2. Dennis 2 wasn't thrilled about it, and he took them apart and he tweaked them. He played with them.
He did, that's right, yeah.
For about a day, and he let us know that. And with that being said, he got them just dialed in the way he wanted them to coincide with our build.
Mm-hmm.
But they weren't stock. They were done stock by Jarrett per Wayne's specs and Holly's specs, but they weren't for our build. They weren't done appropriately.
Yep, gentlemen.
All right, this is
from a home viewer, he writes in. Back then, did they have any wet flow capabilities, or was this mostly dry flow when they tried as far as stagger jetting and mixture? Or
So do we have the prototype?
They probably didn't have O2 sensors in each hole like they do now.
Yeah.
So, with that being said, this is an O- prototype. And this one is one of 25. So,
Is there any possibility we can get the top off?
yeah.
So I just want to make sure that everybody heard the question. The question was there any consideration for wet flow, running into the runners and all of those things? Well, Jerry tells the story after they got these castings back, they showed that they pumped the air. They did what they were supposed to do. But unfortunately, on the interior, a lot of the distribution was not exactly correct. As you can imagine, the outboard were getting rich, inboard were getting lean, and I'll show you exactly what they did. So this is where Smokey comes into play. They sent them down to Florida, and Smokey had a hand in some of this work. Smokey had we were talking about this before. Smokey had a secret weapon. His secret weapon was Ralph Johnson. Ralph Johnson, Holly guy, ex-Holly, right? So Ralph was all about analysis, right? Gas analysis, he was all about flow. So this is where he came in. So you can see those distribution runners here. And if you look at them closely, you can tell that they're hand done. That's aluminum wire with aluminum DevCon. And they were placed in there by, well, initially the first ones were Smokey, and that corrected the issue. And after that, it was all over. I mean, it was just the way it should be. But there's a really interesting story about that too. What they did was they have 25 of those, right? And Jerry, he tells the story where late nights and a lot of beers, we did the work. So he's got the model, which is laying down below, and he's got maybe 20 across the top, 10 and 10. And he's going to replicate each one of those. Well, if you look at this, hold it up and then hold it horizontal. If you flip it 180 degrees, this tub looks the same either way. And he didn't realize that he had it one of them was 180 degrees out. And what he did was he accidentally reversed these. That manifold was taken down to Sebring in '68 and was put on Horchler's car. And I think at that time, Joey Chitwood had seat time in the car. It ran great with the single four. Billy Howell put it on the car. They sent it back out again before the race for a couple laps. It fell flat on its face. And that's because everything inside was just backwards. Who knows what was going on, right? But the interesting thing was back in 2006, Jerry and I got together at a seminar like this, and he had no idea that I had that manifold there. And I said to him, Jerry, is there any reason why these would be different manifold to manifold? And he goes, absolutely not. So then when I showed him the difference between the two, he goes, oh boy, I can't account for that. And then when I said, do you remember Sebring '68? And all of a sudden, in a millisecond, he realized he lost that race. That was that manifold that he did. So it's a great question, by the way.
Yeah, well, I mean, today now with the data that they can get from these engines, somebody could really work and really, with exhaust gas temperature and
great
flow and things like that, they could maybe,
so
improve upon what they had then.
And again, the question is, were these optimized, right? Well, that's an interesting question because what is the parameters, right? What are the goals and so on?
Yeah.
Could they be tweaked a little bit more? And yeah, depending. I think they probably could. What I will tell you is, could you hold this up one more time? So these runners, right? Okay, the equivalent of how do you determine length, right? So you probably know more than I do for sure. But so what they did was these translate into what they did there basically, right? Smokey, he would shorten these up. So your power band has changed, right? So to your point, did they play with these? So Jerry would always tell you that their goal in engineering was to get this out. And then whatever happened after that, if there could be improvements or tweaking or whatever, so be it. That's why on occasion you'll see one of these pop up, and it might look bizarre because there's like modifications to it, and it's confusing, whatever. He's like, you don't expect to see that, but that's what they did. Makes sense. It's a great question.
We had one of those for the Hemi heads once.
So that, yeah, the Hemi.
And it was like cobbled, and it was two of those cut up and put together. A guy in Florida had it.
Yep.
And, it was for the Hemi heads that they had. That they never really. I mean, if they're neat, but they.
So does everybody know about the Hemi heads? The Hemi head package? All right. All right. Does anybody have an idea why it failed? What was it? Say it again?
Oh, I said because Smokey couldn't figure out how to make it work better than what they had already.
Interesting. So the purpose of the Hemi heads, right, was in '68 they began development. They were competing against forged tunnel ports, and they saw them as being a formidable enemy. So what can we do? So Chevrolet is trying to stay ahead of it a little bit. Even though it was clandestine, the program, they figured out how to get money to do the development. But if you look at those heads, they're basically porcupine heads. And what they did was they increased the valve size to 205. And that was like a huge error. Because you got a 302 cubic inch engine, 305-inch valve is just going to kill it, right? So it just flattened it right out. So it just failed. So the rest of the story is those engines ended up in Smokey's shop as payment after '69 when the program blew up. Everybody got their walking papers. Smokey was no exception. Penske went his way. Smokey went their way, Trico. And so in payment, because Smokey felt as though he was not paid enough for his consulting, they offered him the heads and the package and the engine. 4 engines that were completely built, all of the tooling, and they said, go out. We were talking about this, and they said, go out and create your own series now with these. Yeah.
Smokey, when they had a Chevrolet, before they realized they couldn't do anything,
yeah,
they didn't consult with them and say, here, you know, where do you get, what can you do with this? It was only after they figured out they couldn't make it work that they gave it to
so
them.
Charlie Turner actually did the development. Well, he was the draftsman, so he penned it out. He did all the drafting on it. They initially had round ports for the exhaust. They sent it down to Smokey. So Smokey, and you know better than me, Smokey had a lot of time with Pontiac, and one of his pet things was D-ports. And if you see those heads, you'll see the D-port. That's his signature right there. So he played with those a little bit because they challenged him, get some more gains. They just did not have any more power gains. As a matter of fact, they had less power gains. And part of it had to do with the material. They were aluminum. So it just was never going to work. Yep. Great question. Anybody else?
Can we talk about the distributor system, TI? No, you could elaborate.
Your turn.
My turn. So I'm going to ask you a question. Does the cross ram on the 302 run better with the stock distributor or the TI? Oh, sir.
No.
Can you elaborate, please?
No, go ahead.
No, come on.
You gotta give them a sticker if the answer's right.
You're the guru.
Here's a sticker, boss. There you go. Okay, so the question was TI versus points, right? So what is the advantage?
Hotter spark.
Hotter spark? Or is the real advantage that it doesn't float?
Doesn't what?
Float.
Both.
302, high revving engine. It's not uncommon when you're racing the 302. You want to keep it, you always want to finish in a lower RPM, right? But there's those times where you just want to blast by somebody. So 7,200 RPM, let's call that where the limit, right? maybe 76 once in a while, but really it's that. If you have a point system for durability, it's not there. And it's going to float out. And so the TI distributor that was actually meant to work with it or specified for it, there were two. There were 263 and a 267. The difference between the two.
This is a 263, and this is the early Corvette one.
What did they do in road racing? This is a question for me.
Yep.
You know, how did they put a rev limiter on that? Do you know if GM offered a rev limiter chip for that?
I do. I have no idea. Oh.
What?
Valve springs.
So not the driver, because they're not very smart. Drivers are not smart.
I can't answer that. I don't know.
That's a question. That's something Martin
That is,
talked
yeah,
about. And
yeah.
Tom.
On
Yep.
the Ford side, they had a rev limiter on the Boss cars.
That's right. They did, and that's what we talked about. I've worked on some Boss 302s, and I know that it's like I can't remember how that worked. He did have one on this.
That's because he's a baby. He's a baby. It's like, oh, Martin, you want a rev limiter on your car? By the way, that's Martin. That's the guy that the engine got built for. This is you loving it? All right. All right. All right. I just wanted to show that this is the 263. If the difference between the 263 and the 267 is the 267, you don't have to do anything. Out of the box, it runs nice. The 267, you have to mill this bottom in order for it to work with the small block Chevy and change the gear, because this is a reverse drive. Otherwise, the advantage to it is it has a ball bearing in here as opposed to
And that
And the vacuum.
and no vacuum.
and that distributor right there, it from the for me from 1985 in the Cup Series until 1992.
That's
That's the distributor we used in everything. we refitted and put a modern reluctor and pickup on it, but it was a tack drive distributor. In the 80s, we ran the tack drive until probably the mid 80s, and then we all started. We didn't trust an electronic tachometer, and we finally came on board late 80s and said we can get rid of this weight and go with electric tack. But that was the distributor, the body, and I don't know if that was a service part that they made through the 70s, or we just.
This guy was service. The 263 also service, I think, right? Yeah.
Okay.
Yeah, both service.
Gotcha.
Yeah.
Yeah, I was just kidding around about the screen, but what Stahl did, they either used the tack drive, and you could run the tack off of that, and then it had a junction block where you could run two with a short cable.
Right.
He made a fly ball governor where you
Yeah, there you
Right,
go.
we did talk about that. I remember that at the shop. We were talking when we were looking into it.
Yeah.
It'd
That's
be a mechanical.
It was a mechanical, a fly ball, and it kind of shorted out the points.
Yeah.
But the motor filled up when it came back on, and Jeff Miller over there has about 20 of them. When Stahl shut down, he bought them all.
Really?
Yeah. They used to say Stahl, and then they said Stahl Moroso, and then Moroso sold them with his sticker on them, but they were all.
So Jerry Stahl made it?
Yeah.
Really?
Somebody made them, and it was for another. He repurposed them.
Okay.
As
Wow, very cool.
And, when Stahl was closing up, Jeff he bought all those.
Moroso had the same one. They used to put their sticker on it.
What's that?
Moroso had the same one.
Yeah. Well, they were
Okay.
partners, and then they. But that's what they did back then.
Wind it up.
Paul.
I can't hear you, Paul.
How important are head studs? That's a good question.
Yeah, it is good.
It is, because. What do you think about pinning? About what? Pinning that you're talking about the rocker studs now? Pinning?
What do you think about pinning and how important stuff?
Okay, so if we're talking about head studs on the block, and we're probably talking about rocker studs on the heads, right? Two different things.
Screw and studs?
I'd say screw and studs. I've dealt with the other and done it. I was a cylinder head guy way back in the early part. It's a poor man's way of doing it. There's no reason to do that nowadays. You just have a machine put screw and studs in it if you're going to go in that direction. Don't try to ruin your head. The head studs, it works both ways, but now when you start dealing with older blocks, I can tell you right away, put head studs in them. Because I can't tell you, we've all lived long enough, or that stuff's lived long enough out there. If you've got any creaking bones when you get older, you start torquing up a block from 1968 on the mains or the heads, and you'll find out if you do enough of them, and it can get pretty scary.
Chevrolet learned that in 70 with the Preston studs, that the LT1 in 70 with the 186 heads, they started putting the factory screw-ins the next year. So
That's right.
Right.
Yeah.
no sense in trying to do it the old way around.
Yeah.
With the Preston.
But anyways, that's what I would say.
Mm-hmm.
Anybody else?
Okay, we're going to wind up? We're going to wind up now?
I think we need to wind it up here.
All right, we'll give it over to you.
All right, well, thank you, gentlemen. We appreciate you being here and for your fabulous display and your knowledge on the subject of the Cross Ram and the 302. That's going to conclude today's presentation. We are going to announce the awards happening at about 3:15 in the main hall here. So we're actually going to need all these tables and chairs to be moved over there. So we're going to do that now. So thank you so much. All right.
That was good, man.
Yep.